Right now, 20 minutes outside one of the most beautiful cities in Europe, 500,000 people are living directly on top of a supervolcano that just delivered its strongest warning shot in 40 years, and most of the world has no idea it's happening. This isn't a remote Pacific island or some distant fault line you'll never think about again. This is Naples, Italy. This is Campi Flegrei. And on the evening of July 31st, 2026, the ground underneath Pozzuoli did something it hasn't done since continuous instrumental monitoring began, sending residents running into the streets, injuring more than 24 people, and forcing entire families to spend the night outside because going back indoors felt like the more dangerous option. Here's what I need you to understand about what just happened, why scientists have been quietly sounding the alarm on this exact volcano for years, and why a new piece of research is now pointing at a very specific window in the next decade, when everything about this caldera could change. Let's start with the moment itself, because the raw numbers here matter. At 7:46 in the evening on Friday, July 31st, a magnitude 4. 7 earthquake tore through the Campi Flegrei caldera at a depth of roughly 3 kilometers, centered near the Solfatara crater between Pozzuoli and Quarto. Shallow, sharp, and violent. This wasn't some deep, cushioned tremor that rolls gently through the ground and fades. At 3 kilometers down, almost all of that seismic energy slammed straight into the surface with nothing to absorb it. Buildings shook across the entire Naples metropolitan area. People felt it as far away as the islands of Procida and Ischia. Rockslides tore loose from the ridge above the Solfatara crater. Several unoccupied buildings that had already been weakened by years of tremors simply gave out and collapsed. At least 21 people were injured, 2 of them seriously enough to need hospital care, and some reports put that number closer to 26. 18 families were evacuated from damaged homes on the spot. The Pozzuoli port shut down. Rail services and parts of the Naples metro network were suspended for hours while engineers checked for structural damage along the lines. Thousands of residents who felt that first jolt didn't wait for an official warning. They just left their houses and stood in open streets and piazzas because after years of living with this volcano, they know exactly what a bad one feels like. And this was a bad one. It didn't stop there either. A second earthquake, magnitude 3. 8 followed at 10 o'clock that same night in the Gulf of Pozzuoli. And by the time the swarm settled down, more than 30 separate tremors had been recorded through the evening, some of them still reaching magnitude 3. 1. Civil protection officials in Italy came out and said plainly that this was the strongest earthquake recorded in the Campi Flegrei area since continuous instrumental monitoring began, which stretches back decades. It surpassed 2 magnitude 4. 6 events that had already rattled the region back in 2025. Let that sink in for a second. This region had already been setting records for unrest just last year, and now, 12 months later, it broke its own record again. That's not a plateau. That's not a system settling down. That's a trend line still climbing, and it's climbing in a place where the volcano itself is not some distant peak you can point a camera at from a safe distance. It's underneath the streets people are standing on. So before we go any further, subscribe if you want to keep tracking this story, because Campi Flegrei is not a one-off headline. It's an ongoing situation that INGV, Italy's volcano monitoring agency, is now updating on a weekly basis, and I'll be covering every meaningful development as it happens. Drop a comment too and let me know if you've ever felt a volcanic or seismic tremor yourself, because I read every single one of them, and it genuinely helps to hear from people who've actually lived through this kind of thing rather than just watched it on a screen. Now let's talk about what Campi Flegrei actually is, because a lot of people hear the word volcano and picture a mountain with a crater on top, like something out of a cartoon. Campi Flegrei is nothing like that, and that's actually part of what makes it so dangerous. There is no single peak. Instead, Campi Flegrei is a caldera, a vast collapsed depression roughly 12 by 15 kilometers wide, sitting just west of Naples and stretching from the city's western suburbs out to the coastline around Pozzuoli and Boccoli. Picture an enormous sunken bowl carved into the landscape, dotted with at least 24 separate craters, cones, and vents, some of them on land, some of them hiding just beneath the waves in the Gulf of Pozzuoli. The name itself comes from the Greek word phlegra, meaning to burn, and the ancient Romans were so unsettled by the constant steam, sulfur smell, and shuddering ground in this area that they placed the mythological entrance to the underworld right here, at a crater lake called Lake Avernus. This is a place humans have been afraid of for over 2,000 years, and it turns out they had good reason to be. Roughly 500,000 people currently live inside the caldera itself, in towns like Pozzuoli, Boccoli, Monte di Procida, and Quarto. Zoom out further, and the greater Naples metropolitan area holds more than 3 million people, all of them sitting within range of what a large eruption here could actually do. By raw population exposure, volcanologists consider Campi Flegrei the single most dangerous supervolcano caldera on the planet, more dangerous in terms of human stakes than Yellowstone, more dangerous than any other caldera system currently being monitored anywhere on Earth, simply because of how many people live directly inside the blast zone rather than hundreds of miles away from it. Now here's where the history gets genuinely staggering. Campi Flegrei has produced two catastrophic caldera-forming eruptions in its past. The first, known as the Campanian ignimbrite eruption, happened around 39,500 years ago, and it wasn't just big. It was the largest volcanic eruption Europe has experienced in the last 200,000 years, rated a 7 on the Volcanic Explosivity Index, on a scale that only goes up to 8. Superheated pyroclastic flows raced across the landscape at speeds that gave nothing and no one time to escape, climbing more than 3,000 feet up nearby ridgelines and crossing open water in the Bay of Naples to scorch the Sorrento Peninsula on the far side. The eruption punched an estimated 180 to 265 cubic kilometers of material into the sky, blasting sulfur dioxide straight into the stratosphere, where it transformed into reflective particles that cooled the entire planet. Ash from this single eruption has been found as far away as Greenland, buried in ice cores, and as far east as Russia, a genuinely continental-scale event. Some researchers have even proposed that this eruption played a role in the extinction of the Neanderthals, who disappeared from Europe around this same window of time, though more recent modeling suggests the cooling from the eruption mostly drifted eastward, away from where most Neanderthal populations were actually living. So the debate over exactly how much blame the volcano deserves is still very much alive among scientists. What's not in debate is the raw scale of what came out of the ground that day. About 15,000 years ago, Campi Flegrei erupted again in a second major event called the Neapolitan Yellow Tuff eruption, smaller than the first, but still massive by any normal standard. And it's this second collapse that carved out much of the caldera shape you see on satellite images today. Since then, at least 70 more eruptions have occurred inside the caldera at various points, the most recent of which took place in 1538. That eruption lasted 8 days, and in that single week, it built an entirely new mountain from scratch, a cone now called Monte Nuovo, which still stands there today as a quiet, grassy reminder that this ground can rearrange itself in a matter of days when it decides to. Since 1538, Campi Flegrei has not erupted again. But it has absolutely not gone quiet. This brings us to the phenomenon that actually explains almost everything happening in Naples right now, something called bradyseism. It's a slow, rhythmic rising and sinking of the ground surface, caused by pressure changes underneath the caldera, either from hot magmatic gases pushing upward, hydrothermal fluids heating and expanding, or some combination of both. You can genuinely watch bradyseism happen with your own eyes if you know what you're looking at in Pozzuoli. Ancient Roman marketplace ruins along the coast, called the Macellum, have visible boreholes drilled by marine organisms partway up their columns, a literal geological signature showing. The ground sank low enough at one point that the columns were partly underwater, then rose back up again over the following centuries. This isn't a new phenomenon dreamed up by modern scientists to scare people. Bradyseism has been documented since Roman times, and locals have simply learned to live alongside it, adapting their architecture and their daily rhythms to a landscape that quite literally breathes. In modern, instrumentally recorded history, Campi Flegrei has gone through 4 distinct unrest episodes. The first ran from 1950 to 1952, but monitoring equipment back then was primitive, so scientists don't have a huge amount of detailed data from that window. The second ran from 1970 to 1972. The third, and by far the most dramatic of the historical episodes, hit between 1982 and 1984, when the ground beneath Pozzuoli rose nearly 2 meters in just 2 years, accompanied by more than earthquake swarms so intense that authorities evacuated roughly 40,000 residents from the town center as a precaution. And then, starting in 2005, a 4th episode began. And unlike the previous 3, this one has never stopped. It is still going on right now, more than 2 decades later, and it is the longest sustained period of unrest this volcano has produced in the entire era of modern monitoring. Since 2005, the ground inside the caldera has risen by a combined total of roughly 140 centimeters. And across all 4 historical unrest episodes combined, cumulative uplift now sits at around 4.3 meters. The current rate of rise is holding at approximately 10 millimeters per month, which might not sound dramatic on its own, but stacked month after month, year after year, without ever fully reversing, it adds up into one of the most sustained ground deformation signals ever recorded at any actively monitored volcano on the planet. And the earthquake activity tracking alongside that uplift has been climbing right along with it. In February of 2026 alone, INGV recorded roughly 70 earthquakes in a single week beneath Pozzuoli and the nearby Agnano area, with magnitudes reaching up to 5. The following week, the count dropped to 47, still elevated by any historical standard, but a small relief after the spike. Then, on May 21st, 2026, a magnitude 4. 4 earthquakes struck offshore between the Pozzuoli and Boccoli sectors of the caldera, kicking off a swarm of 12 additional tremors before it settled. That event alone was strong enough to prompt precautionary building checks and closures across the area. And then, just over 2 months later, came July 31st, and the magnitude 4, 7 quake that broke every record the modern monitoring system had on file. So here's the honest scientific question everyone in Naples is now living with, and it's the exact same question that makes this story genuinely worth understanding, rather than just scrolling past. Is this magma actively pushing toward the surface, or is this a hydrothermal system? Hot water and steam trapped underground, reacting to gas pressure from below without necessarily meaning an eruption, is imminent? For years, the dominant read on Campi Flegrei's unrest was that this was primarily a hydrothermal story, superheated groundwater and gas doing most of the work, with magma sitting deep and largely passive. A pair of research papers published in 2023 and 2025 leaned into that more reassuring interpretation, focused specifically on carbon dioxide, a gas volcanoes release in enormous quantities. The idea those studies floated was almost hopeful by supervolcano standards, that some of the pressure driving the unrest might actually be manageable, potentially even relievable through controlled degassing approaches, rather than representing an unstoppable magmatic freight train with no off switch. But more recent research has started pulling in a noticeably more serious direction. And this is the part of the story that actually explains why scientists are watching this volcano so closely right now. A study published in Nature Communications examined what researchers call the critical degassing pressure, the threshold at which a sudden, voluminous release of water-rich magmatic gases could heat the surrounding hydrothermal fluids and rock enough to trigger accelerating deformation that ultimately culminates in rock failure and potentially eruption. The researchers behind that paper stated directly that magma could be approaching that critical degassing pressure at Campi Flegrei, sitting beneath one of the most densely populated volcanic regions on Earth, at precisely the moment when accelerating deformation and underground heating are already being observed in real time. Separately, volcanologist Christopher Kilburn and his colleagues at University College London published work in 2023 arguing that since around 2020, Campi Flegrei has entered what they call an inelastic regime of deformation. In plain language, that means the ground is no longer just stretching and springing back the way elastic rock normally does under pressure. It means actual permanent damage, brittle rock failure, is now beginning to dominate over simple elastic flexing. Kilburn put it in a way that's stuck with me since I first read it. With every fresh emergency, the crust gets stretched just a little further, so each new episode of unrest is building directly on top of the damage left behind by the last one. It's less like a spring compressing and releasing cleanly, and more like bending a metal coat hanger back and forth over and over until the metal itself starts to fatigue and crack. Then, in 2025, a separate research team published evidence in the journal Communications, Earth and Environment showing that seismic activity inside the caldera has become progressively concentrated around a specific central plane since 2023, consistent with the birth of an entirely new volcanotectonic fault forming inside the caldera in real time. Not an old fault reactivating, a new one actively nucleating right now underneath Pozzuoli. That detail matters enormously because it tells scientists the caldera rocks have likely already moved past the point of pure elastic response and are genuinely experiencing the conditions required for critical structural failure. And then came the study that's really put a specific number on all of this, one that started making serious waves in the scientific community back in April of 2026. A team led by researchers, including Domenico Zaccagnino and physicist Didier Sornet, who's well known for his work on modeling critical transitions in complex systems, published an analysis on the preprint server Arxiv titled Accelerating Unrest at Campi Flegrei Signals a Critical Transition Within the Next Decade. What they did was pull together decades of seismic and ground deformation data and test whether the acceleration pattern fits a standard exponential growth curve, the kind of steady, ever-climbing trend you might expect from a system just generally getting more active over time, or whether it instead fits something mathematicians call a finite-time singularity, a pattern where the numbers aren't just climbing, they're accelerating toward a convergence point, a specific window in time where the current self-reinforcing trajectory is expected to culminate in a genuine change of regime. Their answer was the singularity model. And when they ran independent estimates using 2 completely separate datasets, ground deformation on one side and seismic energy release on the other, both converged on the same window. Their best estimate points to a critical time horizon somewhere between 2030 and 2034, with the most likely single point sitting right around 2033. Now, I want to be really precise about what that actually means, because it is not the same thing as scientists predicting an eruption date, and treating it that way would be both inaccurate and honestly kind of irresponsible. The researchers themselves were careful to state that this critical time doesn't necessarily correspond to one specific catastrophic event. Instead, it marks the horizon at which the current accelerating trajectory, if it continues along its present course, is expected to culminate in a change of dynamical phase, a shift away from the pattern of behavior the caldera has followed since 2005 and into something new. That something new could mean intensified seismicity. It could mean a structural adjustment deep in the crust that gradually relieves pressure without ever reaching the surface. Or, in the more serious scenario, it could mean volcanic processes genuinely breaking through to the surface for the first time since 1538. All three of those outcomes remain on the table, and right now, nobody, not INGV, not the international volcanology community, not any single model, can tell you with confidence which of those three paths this specific caldera is actually walking down. What virtually every serious study agrees on, though, is the underlying mechanism, and it comes back to something called finite fault modeling, a completely different concept from magma directly forcing its way toward the surface. Multiple research teams applying this approach have separately estimated that the caldera could reach a critical mechanical state somewhere in the early 2030s. And one particularly striking detail from this line of research is that the exponential relationship between ground deformation and the accumulating number of earthquakes is itself a signature of progressive mechanical weakening. The caldera rocks quite literally getting structurally tired from repeated stress, the same way that metal coat hanger eventually snaps, not from one single hard bend, but from the cumulative fatigue of being bent again and again. Now, none of this is being pieced together from earthquake data alone. Underneath the Solfatara crater, one of the most visited and most watched fumarole fields on the planet, INGV runs continuous geochemical sampling, tracking the exact composition of the gas bubbling up out of the ground every single day. What they're watching for, specifically, is the ratio between carbon dioxide, hydrogen sulfide, and water vapor, because that ratio acts almost like a chemical fingerprint of what's happening thousands of feet below. A shift toward hotter, drier, more magmatic-looking gas would be one of the clearest possible signs that fresh material is genuinely rising from depth, rather than the system simply cycling old heat through existing hydrothermal channels. Right now, official bulletins describe those geochemical parameters as confirming a long-term trend of hydrothermal system heating and increased fluid emissions, a slow, steady warming rather than a sudden spike, but a trend that has been consistently pointing in the same direction for years without reversing. Temperature probes inside fumaroles across the Solfatara field have recorded readings climbing well past what would have been considered normal background levels a generation ago, and several of these vents now sit close to the boiling point of water at that elevation, similar in principle, if far smaller in scale, to the kind of pressurized underground plumbing systems that drive hydrothermal explosions at other restless calderas around the world. There's also a human and economic layer to this story that rarely makes it into the international headlines, and it's worth understanding because it shapes how seriously local authorities are actually treating the situation on the ground. Years of repeated tremors have already left visible cracks running through buildings across Pozzuoli, some of them structures dating back generations, built long before anyone was designing for this level of sustained seismic stress. Following the July 31st earthquake, Italy's deputy prime minister addressed the situation directly, pledging full government assistance for displaced residents and committing to what he called a lasting solution for redeveloping and securing every building in the area that inspectors have already declared unfit for continued use. That list of unsafe structures has been growing steadily for years now, not shrinking, and every fresh swarm of earthquakes tends to add a few more addresses to it. Property values in parts of the red zone have taken a visible hit as a result, and local officials have had to balance two competing pressures that don't sit comfortably together, reassuring residents and tourists that daily life in Naples remains completely normal, while simultaneously funding building inspections, reinforcement programs, and a full-scale national evacuation plan for the exact same population. Now let's take a short detour, because Campi Flegrei is not the only restless giant on the planet right now. And putting it in context actually helps explain why scientists don't panic every single time a caldera anywhere in the world starts shaking. Yellowstone in the United States, probably the most famous supervolcano on Earth, has its own long history of hydrothermal explosions and periodic ground swelling. And just this year, monitoring stations there recorded a fresh hydrothermal event at Biscuit Basin, close enough to brand new instrumentation that scientists got an unprecedented close-up look at how these smaller steam-driven blasts actually unfold. But Yellowstone's volcano alert level has remained at normal the entire time, and researchers there are very clear that a shallow steam explosion is a completely different animal from deep magma actually rising toward the surface. Iceland has been dealing with its own extended volcanic unrest around the Reykjanes Peninsula for several years now, with repeated fissure eruptions that, unlike a caldera collapse, tend to be far more localized and far more predictable in where the lava will actually go. And over in the Aegean, Santorini experienced its own dramatic seismic swarm in early 2025. Tens of thousands of earthquakes in a matter of weeks, prompting temporary evacuations before activity gradually eased back down. The pattern across all of these systems is broadly similar. Restless volcanoes generate anxiety long before, and usually instead of, they generate eruptions. But the pattern also shows something else worth sitting with. When one of these systems finally does cross the line from restless to active, the transition can move a lot faster than the years of quiet buildup that came before it, which is exactly why continuous monitoring matters so much more than any single headline earthquake. So let's bring this back to Naples and talk honestly about what a worst-case scenario would actually require Italy to do, because this is where the story stops being abstract and starts being about 500,000 real people. Italy's Department of Civil Protection has spent years building out a formal multi-stage emergency plan specifically for Campi Flegrei, and it currently operates on a 3-tier alert system. Green and yellow represent normal background monitoring, where the situation is watched closely, but there's no indication of imminent danger. And this is genuinely where the volcano has sat for the entire recent unrest period, including right now, despite everything we've just walked through. Orange would be the next step up, triggering the evacuation of hospitals and encouraging voluntary relocation for residents who choose to leave early. Red is the final tier, reserved specifically for phenomena that indicate what officials call a pre-eruptive dynamic, and red is the level that triggers full mandatory evacuation of the entire red zone. That red zone, as currently mapped, covers roughly 481,000 people across the wider region, including 286,000 residents inside Naples city limits alone. If the alarm phase is ever triggered, the plan calls for the complete evacuation of every single one of those people within 72 hours, using a coordinated mix of trains, buses, ferries, and private vehicles, mobilizing transportation resources from across the entire country simultaneously. The plan breaks that 72-hour window into 3 distinct phases. The first 12 hours are set aside purely for preparation, getting traffic control measures in place and giving residents time to gather essentials. The following 48 hours are for the actual mass movement of people, a steady, staged departure scheduled town by town according to detailed municipal transport plans, using 17 designated interchange areas and 29 separate bus routes covering more than 500 stops. And the final 12 hours are held in reserve purely as a safety margin, handling anything unexpected and allowing civil protection personnel themselves to safely withdraw last. Every single municipality inside the red zone has been formally twinned with a specific destination region elsewhere in Italy, which is required to have detailed reception plans ready in advance, covering everything from emergency housing and healthcare access to keeping children enrolled in school without interruption. This isn't a rough sketch sitting in a drawer somewhere. Italy actually rehearses this plan. A large-scale national exercise simulating exactly this kind of evacuation has been run in recent years, and officials have stated plainly that periodic testing will continue precisely because a plan that only exists on paper is not a plan you actually want to be relying on the day you genuinely need it. Here's the detail I think gets lost in almost every viral headline about this volcano, and it's worth pausing on directly. Officials in Naples have gone out of their way to clarify that the evacuation plan itself is not a response to the current bradyseismic crisis happening right now. It exists as standing preparation for a possible future volcanic risk that, at this exact moment, remains classified as remote rather than imminent. In other words, the plan is not evidence that an eruption is coming. It's evidence that Italy learned, the hard way, from centuries of disasters across this exact stretch of coastline, that you do not want to be improvising an evacuation plan for 500,000 people, while the ground is actively falling apart beneath them. You want that plan built, tested, and sitting ready years in advance, whether it's ever needed or not. And that brings us to the honesty check, because I think it matters just as much to be clear about what the current data does not show as it does to lay out everything it does show. As of right now, Campi Flegrei's official alert level remains at yellow, not orange, not red. Despite the record-breaking earthquake on July the 31st, despite the 70 earthquake week back in February, despite 4.3 meters of cumulative uplift, despite a serious peer-reviewed study pointing at a 2033 critical transition window, INGV has not detected any of the specific signals that would normally indicate magma is actively moving toward the surface in the near term. No sudden surge in volcanic gas composition consistent with fresh magma degassing at depth. No dramatic spike in ground temperature at the surface. No sustained acceleration in deformation rate beyond what's already been factored into the existing long-range models. What scientists are watching is a system under sustained, genuinely unprecedented stress, one that multiple independent lines of research now suggest is approaching some kind of structural threshold sometime in the next several years, but a system that has not yet crossed the specific line that would trigger evacuation orders. That distinction matters enormously because the two most dangerous reactions to a story like this one sit at completely opposite extremes, and both of them are wrong. One extreme is total dismissal, treating every headline about Campi Flegrei as recycled internet fear-mongering because the volcano hasn't erupted yet, which ignores the fact that multiple independent, peer-reviewed research teams using entirely different data sets have now converged on the same general time window for a meaningful change in this system's behavior. The other extreme is outright panic, treating a magnitude 4.7 earthquake and a 2033 projection as confirmation that an eruption is basically locked in, which ignores the fact that the researchers behind that very projection explicitly stated their critical transition point does not necessarily mean an eruption at all and could just as easily resolve as an intensified but ultimately survivable adjustment inside the crust. The honest, useful position sits directly between those two extremes. This is a volcano under real, measurable accelerating stress, sitting beneath one of the most densely populated regions in Europe, being watched by some of the best equipped volcano monitoring infrastructure on the planet, with a formal evacuation plan that already exists, has already been tested, and is specifically designed to activate well before any actual eruption, not after one. What should genuinely hold your attention going forward isn't the next single earthquake number, because Campi Flegrei will keep producing plenty of those regardless of what the deeper system is actually doing. What actually matters is whether INGV starts reporting a sustained shift in the composition of gases coming out of the ground, whether the rate of uplift starts accelerating beyond what the existing models already expect, and whether the alert level itself ever moves off yellow. Those are the signals that would tell you the system has genuinely crossed into new territory. Not any single dramatic night of shaking on its own, no matter how many records that single night happens to break. So here's the real question worth sitting with. Naples has lived directly on top of this volcano for thousands of years, through Roman times, through the sudden birth of an entire new mountain in 1538, through 4 separate modern unrest episodes, and the city is still there, still one of the most vibrant places in Italy, still home to millions of people who simply factor a shaking, breathing landscape into their daily lives, the way people elsewhere factor in hurricane season or winter snow. Do you think a place can genuinely coexist long-term with a threat like this, generation after generation, the way Naples has? Or is 2033 shaping up to be the year the maths finally catches up with the geology? Let me know what you think in the comments, because I'd genuinely like to hear different takes on this one. If this broke down the story in a way that actually made sense, hit like, share it with someone who'd find this as fascinating as you just did, and subscribe so you don't miss it if INGV's alert level changes. Because when it does, you'll want to already understand exactly what that shift actually means. Thanks so much for watching, and I'll see you in the next one.